Hello, welcome to Econometrics Melody. In this video, we will discuss about the interval estimate of the population variance. In our earlier video, we have seen that n-1 s square divided by sigma square. This has a chi-square distribution with n-1 degrees of freedom, where s square is our sample variance. This is an unbiased estimate of the population variance. So when we divide this term by n-1, we get an unbiased estimate of the population variance. And chi-square distribution, it is a positive distribution, meaning thereby it ranges from 0 to positive infinity, and it is a right-tailed distribution. We know that significance level denoted by alpha, this is our type 1 error, and confidence level, this is equal to 1 minus alpha. The chi-square distribution is a right-tailed distribution. We can construct two-tailed chi-square distribution following these steps. First of all, we divide the type 1 error into two equal parts, and we set them into the extreme left and right. So this region on the extreme left and right, so this is our alpha by 2, and we will calculate their corresponding chi-square score, and they are different. So as it is a right tail, we begin with the right side. So the first chi-square score is denoted by chi-square alpha by 2 and with n-1 degrees of freedom. So this ensures that the probability of chi-square being greater than this score is exactly alpha by 2. So to calculate the second score, beginning from the right, we reach to a point where the area of the extreme left is alpha by 2. So we reach to this point, and this score is equal to chi-square 1 minus alpha by 2 and n-1 degrees of freedom. So the probability of chi-square being less than this score is exactly equal to alpha by 2. So we have divided our type 1 error into two equal parts, one in the extreme left and one in the extreme right, and their respective chi-square score is different. Now let us see it by the help of example. If we set our type 1 error to be 10%, first of all we divide it by 2, alpha by 2, this is equal to 5%. So the area on the extreme left and extreme right are 5% each, and in between we are left with 90%. So the confidence level is equal to 90%. So how do we calculate the score? So we calculate the chi-square for 5% and n-1 degrees of freedom. We calculate this score, and to the left we calculate it is chi-square and 95% for n-1 degrees of freedom. So the probability of chi-square being greater than chi-square 5% n-1, this is equal to 5%, and the probability of chi-square being less than chi-square 95% n-1 degrees of freedom, this is again equal to 5%. Similarly, if we set our alpha type 1 error is, let us say, 20%, then our confidence level is 80%, and we calculate the first chi-score is chi-square, here it is 10% and n-1 degrees of freedom. We calculate this chi-square score, and here it is chi-square 90% or n-1 degrees of freedom. So in this case, the probability of chi-square being greater than chi-square 10% n-1 degrees of freedom is exactly 10%, and in this case the probability of chi-square being less than chi-square 90% n-1 is also 10%. And to generalize this concept, in the first case we are setting a significance level equal to alpha by 2, and in the second case we are setting our significance level to 1 minus alpha by 2, beginning from right. So if we begin from right, so this alpha by 2, this is equivalent to setting our significance level is alpha by 2. For the second score on the left, beginning from the right, we are setting the value of alpha is 1 minus alpha by 2, and this will ensure the area of extreme left is alpha by 2. So the area away from the type 1 error, we call it as the confidence level, that is 1 minus alpha, and we want our estimate of the population variance to lie within this region. And in probability notation, we can express this information as the probability of our n-1 s square divided by sigma square. So the probability of this score being greater than equal to left score and less than equal to our right score is equal to 1 minus alpha. And we have just seen how to calculate these extreme scores on the left and on the right. Now once we know this relationship, we can estimate the confidence interval of the population variance, and to achieve our goal we will make use of this property. If y is greater than x and less than z and their reciprocal follows this relationship, relationship 1 by y is greater than 1 by z and less than 1 by x. We have just understood about this relationship. Now let us apply the reciprocal property. So this is equal to, let us first of all take the reciprocal of this sigma squared, and we take the reciprocal of this first term. Then after we take the reciprocal of this and we write on the left. And if we cross multiply on the both sides by this n minus 1 s square to the left and the right, so we get our final result. Therefore, confidence interval of the population variance, this lies within this interval. So this percentage of time, we are certain that the variance of the population lies within this interval. Now let us discuss about the one-sided interval of the population variance. First of all, let us begin with the left-sided interval. The lower interval, generally it begins with 0, and the upper interval, it ends at infinity. So the confidence interval of population variance for the left-sided interval, we begin with 0, and at this value, is it is our one-sided interval, so we don't need to divide alpha by 2. So the entire significance level, we have said it is alpha on the left side. So our confidence level is 1 minus alpha. Similarly, for the right-sided or the upper interval, we can calculate the confidence interval of the variance of the population age. So the upper bound is infinity, and we have n minus 1 s square, and we divide it by this score. Now let us calculate the confidence interval of the difference in the means of two normal population. So we have two independent normal populations. The first one is X with the mean mu1 and variance sigma 1 square, and the second a normal distribution or the normal population with mean mu2 and variance sigma 2 square. And from the first population, we take a sample and calculate its mean, and this the distribution of this mean, we can calculate it is where n is our sample size. Now similarly, from this normal population, we can also take a sample and its size is m. The sample mean is given by y bar, and we can also calculate its. Now let us set a random variable a, this is equal to x bar minus y bar, and let us calculate the expectation of a. So the expectation of a is equal to expectation of x bar minus y bar, and if we operate it, and this is equal to. Similarly, let us calculate the variance of a. The variance of a is equal to, and we know that is x and y, they are independent normal distributions, so the variance of the sum is equal to the sum of the variance, and this is equal to variance of x bar plus variance of y bar. So this is our variance of a. Is x bar and y bar, they represent the sample mean from the normal population. So variable a, this is also normally distributed. So variable a, this is also normally distributed with mean and its variance. Now let us calculate the Z score. We know that Z score is equal to the sample mean minus its expectation, that is the population mean, and we divide it by the square root of variance of A. So this is equal to, let us substitute the value. So when Z was equal to x bar minus mu divided by sigma divided by root n, we calculated the confidence interval of the population mean mu is, in this case, this part sigma divided by root n, this is equal to the root under variance of the sample mean. So following same process, we can calculate the confidence interval for the difference of the mean of two normal populations, mu1 minus mu2 age. In place of x bar, we are going to write it as the difference of the sample mean from two populations minus z alpha by 2, and square root of variance, we are going to write it as sigma 1 square by m plus sigma 2 square divided by m. This is our lower interval, and for upper interval we write it as So this is how we calculated the confidence interval for the difference in means of two independent and normally distributed populations. So this is it for this tutorial. Thank you very much for your time. Thank you very much. Econometrics Malady.